Morning, and thank you for joining us for today's webinar, Advanced Coherence Monitoring, Best Practices in Elastic Data Access in a Shared Coherence Architecture. My name is Gia Mangino, and I'll be your moderator for today's event. Our presenter today is Everett Williams, Senior Technology Director for SL Corporation. As Technology Director at SL, Everett is responsible for ensuring that SL's customers are provided with the best possible solutions for ensuring a stable, high-performance coherence production environment. Prior to SL, Everett served as the Senior Programmer and Team Lead for Oracle Coherence at Oracle. He was also an integral part of the highly successful Tangasol step, responsible for developing the original coherence in-memory data grid product. His 10 years of experience at Intel in the areas of business intelligence, process improvement, manageability, and capacity planning, Everett is considered an expert in management services, grid monitoring, and data latency issues at both Tangasol and Oracle. Today's presentation will be approximately 25 minutes with time left at the end to address questions from the audience. If you'd like to participate in this Q&A session, simply enter your question into the chat panel at any time during the event and click Submit. We'll pass it over to you, Everett.
Very much, Gia. So what we're talking about today is the best practices for elastic data access in a shared services architecture. And that's a whole lot of talking about effectively, I've got coherence applications and how to best share my coherence resources across them. So, you've got nodes, you've got and you've got data, and you'll be able to decide going in, how can I best allocate my resources and share these resources across multiple different kinds of applications. And of course, the answer always is, it depends. It depends on values, it depends on what you're trying to accomplish. What we're going to talk about today is really 3 different models for allocating architecting coherence on both a server as well as services, and to come up with a best solution for your particular applications and enterprise. Going and talking about sort of what the trade-offs are between each of the issues we go with, and we're going to talk a little bit about reuse, which is what's the reusability or items you go with, and the kind of corollary, which is isolation, which is I want to not have these resources impacted by this other activity which may be residing on the same architecture. We're also going to be talking about manageability. What's easier to manage versus what's harder to manage, what's better to upgrade, can I monitor it, and really talk about some of the issues that come about for each one of these items. So we're going to start with really kind of the first option, which is, and this was originally sort of the main way of going it, which is we're going to create a single homogeneous cluster. Every cluster is going to run on the same hardware. They're going to share the same services. All the applications are going to use the exact same data across multiple different items. So here's just an example of it. You'll notice we have our hardware down here across the bottom of the cluster. This has some racks and some servers. Your services spread across each one of them, and data. And so go out and do it. You're going to have your data kind of spread across your distributed service that go along. And, you're going to drop in some invocations, which will then get to run across every machine in the cluster. So this basically means you're going to be sharing both not only the hardware, but you're sharing the underlying coherence infrastructure, threads, heap size, etc., along each one of them. So thread pools will be shared and everything across them. You'll also be sharing partitions in this model. So some people love this model. And, it was kind of the original one. You'll have a number of distributed services, small number of invocation services, and every node and server will look pretty much exactly the same for each app. Benefits of this. You get complete reuse. So you never have threads that are sitting idle because you aren't using that application at the particular time. Those threads will be running something at some given time across each one of them. Let's get join capability as well as transaction capability across the cluster. You get challenges, right? This one's also pretty easy to configure. You only have really one configuration to go through and deal with it, so it makes it pretty simple. However, you have a significant problem with change analysis. When new applications come in, because they're sharing the same resource pool, there's very little isolation, which you'll notice there's heap usage isolation as well as CPU isolation, level isolation. Each items are now shared. So when you get some change to an application, maybe in a new application as a whole, understanding its impact not just on itself, but other applications which may reside within the same cluster and the same grid, you as items. Now, you would also deal with capacity management. I have enough. The one that I find is really difficult in this one is if you are using high units, those numbers are allocated on a node-by-node basis. As you add new nodes, if your cluster is growing at different sizes for different caches, you then have to go out and reallocate the numbers across every cluster across every node. So it's somewhat complex to dealing with your capacity management. I'm going to show you, I'll flip over a quick demo, is something that we talk about in change analysis. And what basically is a screen within RTView. We do time range comparison between a particular cache on a particular run. So within items, you get to select your coherent service as well as the cache that you're looking at. And then you get to pick two time ranges. And you'll notice here that I picked yesterday from 8 a.m. to 8:16 a.m. to 9:16 a.m. and then from 9 to 10. And this would simulate something. So you're in your test environment and you run a test at 8 a.m. with one application, and you might have another version of that same application that you might have run a different server an hour or so later. And you see an aggregate level across these 2-hour runs, fixed. You want to see, how they impacted the actual cache underlying. And what this does for you is it does the number of puts, gets hits, and then store reads, writes, store failures as millis across this service, and it then does a comparison. So what this is doing is it's basically all the data across the time range, saying how many gets did I do from this time to this time, and pairing it and providing you a delta range. So in this case, you'll notice that our percentage change from our 8 to 9 range and our 9 to 10 range was very small. So this can give you an item that says we are consuming, from a cache perspective, more than 2% difference or 1.5% difference based on these two different versions of the application, which means there should be very little impact for the version of the app. And this will help you deal with this sort of capacity problem within a change impact analysis. So we'll also look at, why we want this cluster. So you look at it, if you're having a lot of shared data, where it is actually highly related, and you're doing either cross join or you're doing transactions, and you have maybe a pretty static system, you wouldn't hit the issues of change analysis very often, and your isolation would be minimal. Requirements would be minimal. Also, when you deal with issues like this, frequently it's good to have this environment sort of a single owner. So if you do have issues like, app A is impacting app B, you have one person who can go make that call, or, a set of people who actually make an agreement to actually, app B needs to use less resources and give it to app A. That we have here is you can go with a single cluster, but you can make it a heterogeneous one. And effectively, this is not every node in the cluster is going to join every service. So have maybe 10 in one service and then maybe 15 in another. It allows you, just give us a quick demonstration. Same like we have, our 8 servers across the bottom. We have one cluster service, maybe one or a couple of proxy services. And distributed services may be across different levels of hardware. And so this model, your data from each app would be going into maybe each distributed service, but the data is shared between apps. And in the model, you can run your invocations across different invocation services based on the information you need. So what is it? Because writing this across multiple CPUs, you can get some level of CPU isolation. You don't always get that, but you can get some level of CPU isolation. You also have some level of heap isolation because each app's data is residing on different heaps and different JVMs. You also get some isolation levels there. You also have, and thread level isolation because you could define a different thread pool. If you have like a hung thread on one app, one service, that does not impact anything else. You don't end up with like a backup where, say you have 2 slow running queries and only 2 threads allocated. Those 2 queries don't impact and cause just like task backlog on that particular service, and it can be spread more evenly. However, you end up with several. You don't deal with you have a complex configuration. You can do joins and transactions. Have infrastructure isolation issues, which basically means because you're running a lot of the stuff on the same hardware, you still have to deal with network and things like that. Now, one we wanted to look at is like a CPU isolation screen within the monitor. What the CPU isolation screen does is looking at every service in your cluster and how it is impacting the CPUs that are actually being burned across these items. You'll notice in this one, the way this is read is each column is a sample of data for the CPU, and each row is a service. So this allows you, because you have a lot more services on these, and they may be sharing CPUs, you can actually go out and look at services that are running and what amount of activity within the CPU you're looking at on each service. So this gives you the ability to analyze across many services the amount of CPU they're doing across this heterogeneous cluster. You get one other major feature that I'd like to point out, which is the ability to really actually go out and look at your cluster and understand what those items are. So you'll notice here, you can see both the service name as well as the location of nodes from nodes within the cluster or the service, as well as the storage nodes and the cache nodes. Now, this gives you the ability to actually go out and look at how many are actually being used on each cluster. There's another option in our model. Okay, so basically this comes out and says, well, I've created these 2 large clusters, and one is, I have a very little isolation level. The other one, I have a significant management problem. I've got lots of impact across them. So one way to avoid this is to go with a multiple cluster model. And we're seeing this more and more there where people are deciding, I may have different upgrade times on the cycle. I may have different data domains or different owners in the data domain. So what I want to do is I want to create multiple different clusters, and the coherence extend to go in and access those data through multiple different apps. And you'll see in this one, each one of them will be segmented across them. We'll have a different cluster service, invocation service. This will run where data actually resides for each spread across the same hardware. Now, you get complete isolation across the data domain. So each data domain, you don't have problems with CPU, you don't have problems with threads, heap is taken care of. So you don't really have much in the way of those items, which is a major benefit to this architecture. However, with some challenges that you're now managing more clusters. From an example of what alert state of my clusters, you need to worry about that. You have difficulty joining data across or using transactions across the clusters. So data segments definitely need to be mutating perspective or join perspective, or you have to then do them in the client, which is a challenge and not very scalable by nature. And then the issue of understanding sort of application performance across cluster. Since each application is now connecting to multiple different clusters, you now need a tool that will actually allow you to say, what is this app connected to? And if it's slowly, how do I go about dealing with it? So we're going to a couple of screens here that are part of our Enterprise Manager product that help you address some of these issues. And what you're looking at here is a proxy screen. Let's pop over to this one first. What we're looking at here is actually the multi-cluster overview with our Enterprise Monitor product. What it allows you to do is it allows you to see all the clusters that are participating in the application. So from here, you can see the risk clusters I might be managing, or a growth cluster, an opportunity, or a fixed income cluster. You get to see, how many nodes are in each cluster, as well as, clients' proxies, or how many remotes you have. Activity from arrests or tasks. You see your number of gets, puts, misses. And what you also get to see on each one of these is, because you want to see a trend, the number, 10 million doesn't necessarily mean much to me. We provide you with an analytic that basically allows you to determine, what's the expected value of this item, which is a weighted average in this case. And what is the actual percentage, what's the size of this? And you'll notice that this particular one is 400 is the actual number that we normally get out of it. So we normally get 2 million. And a 10 million number. The number is very high and the error is pointing up. Where you might have other ones where the error is pointing either down or to the side along to tell you the value. You get to see the backlog, right? If you're in this environment where you're connecting to multiple different proxies, your proxy backlog contains the amount of data that is sitting on the proxy and has been shipped to the client. Understanding the amount of that's waiting will determine performance occurring on each one of them, as well as the backlog for any particular connection. And you'll notice here it's 997. Now, model, after understanding what's going on, frequently you'll have customers call you and say, my app is running slow. This one you would be able to say, well, okay, what connection, where is it connected, what clusters is it connected to, and how do I determine that? And normally what you would do is, if you're using some of the other tools out there, you would either have to go in and look at the JMX connections, go to multiple JMX areas within the coherence management nodes and find them. What we have here is we have a filter that allows you to actually go in and type in, say, the IP address of a particular node that you're looking for. And let's pick one that we can see here. So it's 0.0.10. And when it brings up the address node, you can quickly find where this user is connected to. And it'll allow me to actually go in and look at a proxy connection. So I know what nodes it's connected to within the proxy and whether I've been having any issues with those. You can look at both the task log for this individual item. You get to receive the bytes received sent for this particular app and where it's done, as bytes sent and received per second. You also get to see the aggregate up here of these values, and in a stacked bar graph on the cluster. So you can see that the byte backlog for this item are here and here, as well as that. And this takes something that normally is a very difficult time for our customers, determining where these things are connected and finding them. So it's really quick to satisfy. So we went from the customer that we were working with, went from we don't know the answer to I can tell you within 30 seconds which clusters you're connected to and whether the state or health of those clusters is impacted or whether at. So it was significant time it took them to actually figure out, where the issues were occurring, whether it was an app or a coherence issue. I'm right, apparently. So, a little bit, just kind of throw out one of the challenges within monitoring. Here's when you get these issues in the items. Here's sort of the kind of capabilities that we deal with. For whether it's health monitoring, scalability analysis, event analysis, bottleneck capacity. And our tools in SL and our tools are focused on solving these lists of problems for you. I believe I am out of time, and we will go ahead and open it up to questions.
Well, thank you so much, Everett. I would, again, like to invite the audience to submit any additional questions by entering them into the chat panel or into the Q&A section and clicking Submit. If not able to get to all of your questions during this live event, we'll be sure to follow up on any unanswered questions via email. I'd like to let everybody know that we are recording this webcast, and I'll be sending an email link in the next few days. We will also be doing an encore presentation this Thursday morning at 8 a.m., and you can visit our website for the link. And if you found it useful, please invite any of your colleagues to attend that session. So let's get started. Our first question is, why are joins and transactions difficult in the heterogeneous cluster scenario?
The reason for that is that transactions in coherence are partitioned, so the data must reside within the same partition. You can get key partition affinity using the key associators within coherence to force objects of particular types into the same partition. That you don't have that capability when you go to across a service or across a different cluster. So you need to understand that before allocating your data and your capacity.
Thank you. One other question. In a homogeneous cluster, what are some of the reasons you might want to create a new service?
Normally our issues with that are either some particular setting, right, is required across each one of them. For example, task timeout, one of them. You don't want tasks running longer in certain services. Backup count, distributed services are frequently on the lines. Sometimes it's sometimes just simply a management issue. You want to maintain capacity across each one of them, and you want to monitor them differently. And those are normally the items that we come up with where people are like, yeah, I'm going to go ahead and create a service.
Great, thank you. Can you query traffic volume to resources utilization such as CPU and GC? The question is understanding whether you're executing an entry processor or an aggregation and how that impacts the overall items. And the answer is yes. We have one screen. Let's see if I have a demo available. So if you're looking at our host service history, one is not running anything on it. Let me see. I have one screen out here, which is our service history. And again, I don't have a good demo. Effectively, what we're doing in the screen, and I'll quickly explain it, is we're mapping our level of tasks right down and on a CPU. So this allows you to blend the data so that you can come back and say these tasks are burning this amount of CPU at the host level. So by using our enterprise monitor product and getting host statistics off of the hardware and the coherence statistics out of the coherence monitor and correlating them in a single screen within the history heat map, you can actually compare the activity to the CPU activity at the hardware level, which will give you a feel for exactly what your impact is. Okay, well, thank you for that, Everett. Let's see. Is it possible to restrict memory being used by coherence, and can that be controlled by an app like a Java app?
Memory being used. If you're talking about at the OS level, I'm going to have to get back to you on exactly that one. And can we take the name of that one? Because I'd like to kind of maybe talk to them about what they're looking for on that one.
Yes, absolutely.
So if you said something about that, that'd be great.
Okay. That is all the questions I have. I don't see any else coming in. So thank you for your time, Everett, and thank you everyone for joining us. Again, we'll be doing this presentation on Thursday at 8 a.m. if you'd like to invite any of your colleagues. Thank you and have a great day. day.
Thank you, Gail.